Alright, in this video, we're going to be reviewing reference triangles and oblique triangles. Now, reference triangles are triangles that I can use when I'm drawing angles in a coordinate plane that help me determine trig values for that angle. In this first question, I have a point -4, -3, and that point is on the terminal side of my angle theta. So I'm going to go ahead and plot that point on the coordinate plane. -4, -3, of course, would be in the third quadrant, maybe about right here. And I'm going to connect it to the origin. That would be the terminal side of my angle theta. So here's theta. Now I want to draw a reference triangle. The reference triangle is always going to be drawn to the x-axis because it contains the reference angle. And the reference angle is always that little angle between the terminal side and the x-axis, which would be right here. So I have this reference triangle. It is a right triangle. Coordinates of this point are -4, -3. And so my x-coordinate is -4. That means that the horizontal side of my triangle has a length of 4 in the negative direction. And the vertical side of the triangle has a length of 3, also in the negative direction. And now I need to find my radius. I know that the numbers 3, 4, 5 make a right triangle, and so my radius here, the hypotenuse of my triangle would be 5. Now that I have all three sides of the triangle, I can find any trig function that I want to. In this case, we're asked to find sine and cosine. Sine theta, the ratio for sine is y over r, or you could also use opposite over hypotenuse. And either way, for this triangle, we get -3 over 5 for sine. We're also asked to find cosine. The ratio for cosine is x over r, or adjacent over hypotenuse. And for this triangle, that would be equal to -4 over 5. All right, let's try another question here, number 12. Now here we're told that sine of theta is equal to -12 over 13, and cosine of theta is greater than 0. So I want to draw a reference triangle. First thing I've got to do is figure out which quadrant that triangle is going to be in. I know that sine is -12 over 13, but at this point what's important is to realize that sine is negative. And I know that that happens in quadrant 3 and quadrant 4 because sine corresponds to the y coordinates. Cosine greater than 0, that tells me that cosine is positive. And cosine corresponding to the x coordinate is positive in quadrant 1 and quadrant 4. And so the only place where both of those things are true is in quadrant 4. And so that means that that's where my angle is going to lie, in quadrant 4. So I'm going to draw a coordinate axis, and I'm going to draw an angle down here in quadrant 4. And then I'm also going to make my reference triangle. Remember, always drawing that reference triangle to the x-axis. So now let's go back to the information, the first piece of information that we were given. Sine theta is equal to -12 over 13. Now I know that the ratio for sine is y over r. And so I know two sides of my triangle. In fact, any time that you have a fraction representing a trig ratio, if you've got two numbers there, that means that you've got two sides of a right triangle. And all you have to do is do Pythagorean theorem to find the third side, and then you can find any trig function that you want from there. So for this problem, my y is -12, so that's this side, length of 12 in the negative direction, and my radius is 13. So that goes right here. Now we can do Pythagorean theorem to find that horizontal side. Since I have the hypotenuse, I'm going to subtract 13 squared minus -12 squared, and that's going to give us 25. And then, of course, I need to square root 25, and so my x side will be equal to 5. Now, when we do this, we need to think about whether or not that's in the negative or the positive direction. But it's, in this case, it is in the positive direction, so we're going to leave that as positive 5. Now I've got all three sides of the triangle, and I'm ready to answer the question that was asked. We were asked to find tangent of theta, and so tangent of theta, the ratio is y over x, or opposite over adjacent, and in this case that would be negative 12 over 5. All right, let's move on to the next question. In this question, we've got cosine theta is equal to negative 40 over 41, and the terminal side is in quadrant 2. So this time they just tell us where the terminal side lies. So I'm going to draw an angle in quadrant 2. Draw my reference triangle. And if I know that cosine is negative 40 over 41, that ratio is x over r. And so my horizontal side here is 40 in the negative direction. My r is 41. And so we need to find the other side. So we're going to plug into Pythagorean theorem. Again, here I know the hypotenuse, so I'm going to subtract. 41 squared minus negative 40 squared. And if you put that in your calculator, you're going to get 81. And then we need to square root that number. And so my y side, which is what I'm missing, is equal to 9. Now this angle is in the second quadrant. And so in quadrant 2, y is positive. And so I'm just going to put positive 9 there on the y side. And now we're ready to answer our question. They asked us to find sine of theta. So sine theta, y over r, 9 over 41. All right, last one. We've got tangent is equal to negative 8 over 15. Sine is less than 0. So again on this one, the first thing we need to do is figure out which quadrant we're going to draw that angle in. This first piece of information tells me that tangent is negative. And tangent, remember that tangent is equal to y over x. It's also equal to slope. We talked about how tangent really is slope of the terminal side of the angle. And so that's going to be negative in quadrant 2 and quadrant 4. Now the second piece of information, sine less than 0, that tells me that sine is negative. Sine corresponds to the y. And of course y is negative in quadrant 3 and quadrant 4. So the one quadrant where both of these trig values are going to be negative is quadrant 4. So that's where we're going to draw our reference triangle in quadrant 4. There's our reference triangle drawn to the x-axis. And the given information here, tangent is equal to negative 8 over 15. Now my tangent ratio is y over x. On this question, we need to be a little bit careful about that negative sign and make sure that we get it in the right place. It doesn't go for both y and x, only for one of them. And since I'm in quadrant 4, the negative is going to go with the y because y is negative in quadrant 4. So I'm going to have negative 8 here and 15 here. Now we need to find that radius, the hypotenuse of our triangle. So we're going to use Pythagorean theorem. And that's going to be equal to 289. And then, of course, we need to square root. And so our radius here is going to be, whoops, I put two equal signs, is going to be 17. And now we're ready to answer the question we were asked. We're asked to find cosine theta. Cosine is x over r, and that would be equal to 15 over 17. And so that brings us to the end of the reference triangles. Let's talk about oblique triangles. Remember that oblique triangles are non-right triangles. And whenever we have a right triangle, like we've just been dealing with, we can use regular trig ratios. But when we have non-right triangles, if we're going to find missing information, we need to use law of cosines or law of sines. On this first one, if a triangle has sides with lengths 11, 15, and 9, what is the measure of the smallest angle? So I'm going to draw a quick sketch of a triangle. 9, 11, 15, A, B, C. All right, and so how I drew this triangle, my smallest angle is going to be angle C, because the smallest angle is always going to be across from the smallest side. So angle C is my smallest angle. Now whenever we have all three sides of a triangle, that's an indicator that we need to be using law of cosines. Because if you remembered, in order to use law of sines, we need to know at least one angle and the side across from it. I don't know any angles here, and so I have to use law of cosines. And I'm going to use law of cosines that starts with C, because that's the angle that I'm using. So C squared is equal to A squared plus B squared minus 2AB cosine big C. And since I want to find angle C, I need to solve this for cosine C. So I'm going to subtract A squared and subtract B squared from both sides. So C squared minus A squared minus B squared equals negative 2AB cosine C. That negative 2AB, it's got to stay there with the cosine C because all of that is being multiplied. All of this is one term, and we got to keep it together. But now I can solve for cosine C by dividing, because these are all being multiplied, so I can divide by negative 2AB. And so cosine C is equal to C squared minus A squared minus B squared over negative 2AB. And so now I'm ready to plug in all of my information. C is 9, so 9 squared minus 11 squared minus 15 squared over negative 2 times 11 times 15. And that equals cosine C. Now remember, anytime that we are trying to find an angle, anytime you're trying to find an angle using trig, we're actually going to use an inverse trig function in our calculator. And so if I simplify this fraction here, I get 53 over 66. But in order to find angle C, I need to use inverse cosine on my calculator. Make sure that your calculator is in degree mode, and inverse cosine is going to give me an angle C equal to 36.579 degrees. And that's going to be the smallest angle of our triangle. Let's go to the next question. We've got two streets bounding a triangular lot. They make an angle of 74 degrees. And the two sides of the lot are 110 feet and 126 feet, and we want to build a fence. So how much fencing will we need? Well, if I label this triangle, I'm just going to label it ABC like this. So I'm missing side A, but we know side B and C. And the information that I have given here is I have a side, an angle, and a side. We have side, angle, side. And so that means that I need to use law of cosines again. In order to use law of sines, I've got to have an angle and a side that are across from each other, and I don't have that here. So law of cosines it is. And we need to find side A. So a squared is equal to b squared plus c squared minus 2bc cosine angle A. And so I'm going to substitute our information in here. 126 squared plus 110 squared minus 2 times 126 times 110 times cosine 74 degrees. Again, make sure your calculator is in degree mode, and we can enter all of that in, and we get a squared equals 20,335.332, which is obviously not the length of the side. We need to square root. And so A is equal to 142.602. And so that's the length of our third side of the lot. But the question said, how much fencing do we need? And so really we need to add all of these together. And so if we add the 142.602 to the 110 and the 126, fencing, we need 378.602 feet of fencing. All right, let's try the next question. In this question, we've got some information given to us about triangle ABC. So I'm just going to draw a triangle, label it ABC. We know that side A is 14, so that's going to be across from angle A. I'm going to put 14 there. Angle C is 57 degrees, and angle B is 45.6. I don't think I can fit that in my little triangle, so I'm going to do this. All right, so on this question, the information that we're given, we have an angle, a side, and an angle, side, angle. And that means that we need to use law of sines, because I can't use law of cosines if I have two angles. But remember, with law of sines, we need to have an angle and the side that's across from it. And I don't have that here. I have side A, but I don't know angle A. And so we need to find that by adding together our angles and subtracting from 180. And if we do that, we get that angle A is equal to 77.4. So now we have enough information to use law of sines. Sine of 77.4, that's angle A, and so that needs to go over side A. And then we want to find side C, so I'm going to use sine of 57 over side C. And if I cross multiply here, then I get C times sine of 77.4 equal to 14 times sine 57. And then we're going to divide to get C by itself. So C is going to be equal to 14 times sine 57 divided by sine of 77.4. And if you put that in your calculator, you should get that C is equal to 12.031. All right, last question here in this section. Triangle DEF, we know side D, we know side E, we know angle F. And we need to find side F. DEF, side D across from angle D, 9.5. Side E across from angle E, 11.8. And angle F, 82 degrees. And we need to find side F. So I've got side, angle side here. Side, angle, side. And so that tells me I need to use law of cosines again. F squared is going to be equal to D squared plus E squared. minus 2d e cosine f. And so that's equal to 9.5 squared plus 11.8 squared minus 2 times 9.5, 11.8 cosine 82. And if we put that all in the calculator, we get f squared is equal to 198.287, which is obviously not the answer. We need to square root, and f is equal to 14.081.